Awesome. So today, as they already stated, we're going to talk about, what a data lake strategy looks like with AWS, specifically going into depth about the data lake concept and just understanding, what that means as it relates to how you can leverage that with the AWS platform. So brief introduction. I'm Corey Harris, a solutions architect. I've been with AWS for about 9 months now. Had a lot of experience in financial services prior to AWS. And, I'm excited to help you all really deep in the serverless space as well. For all of those who may be interested in serverless technology, I'm definitely your guy. I also have with me Michael Brown. He's our senior solutions architect. He's been with AWS for a number of years now. He has a very deep knowledge of manufacturing, over 20 years of experience. And he'll also be available to, chime in during the presentation as well as the Q&A. We also have Zachary Waters. He's our He's one of our account managers at AWS. He's covering this area, so he'll be a very common name that you'll see, in the upcoming months. So with that being said, let's dive into, just what a data lake is and kind of get ourselves indoctrinated. So, a data lake, when you think about a data lake, I want you to keep in mind the concept of uncurated and truly raw, right? So, an easy analogy is when you think about water and you think about, the different flavors and types of water that you can get from, a water company, whether it's spring water, purified water, distilled water. Essentially, it all comes from some central place. That central place is, in this context, a data lake, right? So it's raw, and from there you have multiple downstream or plants that take that water and turn it into a certain type for an end customer, right? So when we talk about data lakes, with customers, it's very important that when you build a data strategy, that you do have this concept of, I have a central repository for structured and unstructured data, keyword unstructured, right? Because, you want to be able to know where your source of truth is at all given times, right? This enables customers to really leverage advanced analytics and not lose any key insights from their data that they may not have built as a part of a data warehouse strategy, right? So, a common concept of the data lake is you store the files as is, right, in their open source file formats. So whether it's CSVs, log files, streams, etc., the data lake allows you to store those files as they come in, right? And then we can talk more about what happens once they get there and best practices around that as well. So, why data lake? Why is it important? The main reason is, one of the reasons is you want to decouple your compute from your storage, right? And this gives you the ability to effectively scale. So what I mean is, in the traditional world, right, I came from a Teradata shop, and, Teradata is an awesome product, world-class infrastructure, great performance profile. The problem with Teradata, or some products like Teradata, is just the way that it scales as you grow. So if you want to, add more data into your data warehouse solution, one, it's predefined schema, so it's a little bit of limitation there. But two, from the scaling standpoint, there's no decoupling from your compute and your storage. So those grow in parallel, right? So it doesn't allow you to take advantage of scale without, breaking the bank, if you will. And also another common reason to get a data lake is you want to reduce the complexity in ETL and operational overhead. So think about it this way. You have multiple lines of business. They all maybe use their own technologies. They have their own ETA for when data is available in the data warehouse. They may even have their own definition for the same customer, right? So in my experience, my last company, each line of business insurance, personal, bond, sureties, they had their own definition of what a customer was. And it was very tough to put together a golden record of when the customer leveraged our mobile platform or was interacting with an agent, how do we know what they really have, right? Why do we have to keep bringing them to different departments and making the customer experience, less optimal, right? Things of that nature. Those can be mitigated when you have a data lake strategy, right? Because it forces the centralization of the data. And now, as a collective, you can have more of a strategic approach as to how you prepare and how you curate data sets for end customers, right? And again, another big piece, and maybe one of even the biggest ones, is the future extensibility as new database technologies and analytic technologies come about. The data lake is not a vendor-specific product, right? So we'll talk about what that service is later, but our data lake solution, so this landing zone, if you will, for raw and curated data, has no vendor-tied data strategy attached to it, right? You don't have to take an AWS-specific route to, get insights from this data. It's literally just a place where you can land data. It scales gracefully, high redundancy and endurance, and availability for your actual data, right? So again, it gives you the ability to determine, what products you want to leverage when new open source, technologies come about. You have that agility to be able to leverage those at will, right? So traditionally, this is kind of what the data strategies look like for most businesses. You had your transactional systems, your ERPs, right, your LOB databases and whatnot. Typically, they were always relational, right, because they were going to a place like Teradata or, another data warehouse solution. You're dealing with terabytes of scale, schema defined prior to load. So there was a limitation on how easily you could ingest new sources. So in the case of mobile or, within the last decade or so, when social media became a buzz for companies to want to gather insights about what customers are saying in regards to feedback about experiences with their platform and kind of mapping it back to, customer engagements and activities, that is cumbersome with a solution that's, predefined, or a data warehouse solution with a predefined schema. And also the CapEx, right? So, with these solutions, again, there's a large investment up front. So you kind of front load your cost, and it puts you in a position where, some companies become, very concerned about how quickly they can return on investment, with that kind of solution. So with the data lake approach, there's this notion of decoupling each layer. So as you can see from the bottom, you have a lot more sources that can easily integrate with the data lake because, again, the schema is defined on read, not on the actual write, right? So when you land the data in the data lake, really the only concern is just the logical separation that you put the data in. So you want to, and we won't get into that in depth today. I can definitely take questions on that, but we do have best practices in, how do you land data, to make it more effective to do ETL, right? Based on the partitioning and letting the data lake technology work in your behalf, right? So there are best practices on that, but there's no schema definitions. You can just throw data in the data lake, and, on top of it, we have the notion of cataloging, which basically allows you to build a data dictionary, right? So you can know, what data you have, things of that nature. And again, on top of that, we have services that can leverage that catalog to be able to use that as almost a table of contents, right? Considering the data lake itself has no schema, the catalog is really where those services go to understand where data resides. And that can be data warehouse services, big data services like Elastic MapReduce, machine learning services, and also dashboards services that we have, right? So again, this decoupled approach, gives you the ability to determine which route or which analytic journey you want to take without the initial investment of, picking a solution and kind of dealing with whatever, journey that solution allows you to have. So, one of the benefits, again, of the data lake is, all in one place, right? So as we talked about, store and analyze all of your data from all of your sources in one location. Again, it just makes it a lot easier when companies are trying to determine an appropriate data strategy, or when you're going into the IoT space, right? With all of these new technologies where data streaming and data collection is becoming a necessity for any customer that wants to, for example, prevent failures in their manufacturing plants, right? We have customers, like Georgia Pacific, who went down that exercise of, they wanted to be able to preemptively prevent outages from their plants, right? Which directly related to them losing money. If a paper machine goes down, if a convertible mill goes down because of tears during the manufacturing process, that's money burned on the table, right? Millions of dollars across over 150 plants, right? So, what they were able to do is say, hey, I want to leverage a data lake solution where I can bring all of any relevant data to kind of help me understand why this outage or why these errors occur, right? Why are based on the materials, the temperatures, the calibration levels, right? Let's bring all that data in and let's start doing some machine learning and start training models so that our operators can preemptively say ahead of time, we detect that there may need to be some, high-level maintenance done to prevent a wide outage of a machine, right? And with this solution, they were able to pretty much preemptively predict within 60 to 90 days, of when a machine or an outage would have occurred, and they can mitigate those actions proactively, right? So this is becoming ever more important for customers because, again, customers are trying to grow at scale. You want to optimize your resources. So having that data in one place, it really makes it easier to determine, what do you do with it now, right? From an ingest standpoint, because the data does not have to be predefined into a schema, right? The ingest, happens rather quickly, right? And we have over 11 different data ingest capabilities within our platform, ranging from streaming to database migration services to, block level replication, as well as, the ability to send, a device to a customer and load petabyte scale data into an actual durable device. And then we load it into our actual data center directly, right? So there's a number of different ways that we can bring either massive, small amounts of data, incremental data into the platform. And because the schema on read is the paradigm, you don't have a limitation, right, on your ability to at least get it into your ecosystem. And within that, you can determine how to refine, logically separate, the data as is. So one of the biggest pieces I've talked about, is the storage versus compute, right? So if you think about it this way, let's say I'm running some EMR, so Elastic MapReduce, and I have a 3-node cluster, but I'm bringing in new data sources, right? So my storage footprint is ever growing. If I'm comfortable with the data lake solution, I can remain with a 3-node cluster on the EMR side, right? And my storage footprint just naturally grows, right? And it naturally scales on its own. And I'll talk a little bit about our technology that allows you to do that. But this is the benefit of the data lake, right? You can decouple, your compute from your storage. You don't have to grow those in parallel. If you don't need massive compute, you can still have lightweight compute, but just gather more data. Whereas in traditional models, that's, a lot harder to accomplish and sometimes impossible. Those may have to grow in parallel, which can, of course, spike up your actual initial investment. So again, like I just spoke about, right, the schema on read, very, very important benefit of a data lake. It allows, ad hoc analysis, right? Because now what I can do is based on the consumer of data, I can determine which schema they can be exposed to. So for example, what you have the ability to do with the data lake is I can create multiple versions of a data catalog, right? So I can have the same underlying data lake storage. On top of it, I have multiple data catalogs, and those can be created based on my consumers. So I may have one data catalog with a version of a schema and a separate data catalog with a slightly different version of a schema based on who's going to be consuming that data, right? So it enables this notion of ad hoc analysis and really giving people different views of the same information, right? I have the same data, but because the abstraction on how I catalog the data and the flexibility I have in me creating these data catalogs for my downstream applications like data warehouse systems or ad hoc querying systems or dashboards, or, a data pipeline for machine learning, I can leverage any data catalog at any given time, right? So I can meet the needs of multiple consumers within my enterprise. Again, so it gives you, infinite flexibility on how you can, slice and provide that data. So let's talk a little bit about why AWS. So when you think about a data lake, you probably already can tell that it requires a broad set of tools and technologies. And the main reason is because the application set is so diverse, right? So with IoT data streaming, with the current pandemic, a lot of companies are leveraging virtual reality or certain levels of augmented reality to be able to interface with customers, especially in like the real estate space, the Airbnb space, right? Those kind of industries, data, being able to accommodate that without breaking the bank is huge. I mean, you have to have a platform that's flexible and ready for change at any given time, right? Things that no one would expect to happen, happen in this world, and your technology needs to be able to allow you to adapt to that so that your business can continue to thrive and you can continue to give, great experience to your customers. So, the typical steps for a data lake, and again, we'll dive deeper into this, is, you set up your storage solution. We'll talk a little bit about that. You move the data in, you cleanse, prep, catalog. So this is pretty much your ETL. You then configure and enforce security and compliance policies. This is important, especially for customers who have sensitive data sets. So you want to have a platform that allows you to create this fine-grained control, as well as, the ability to administer these policies with ease and with certain levels of abstraction, depending on how much you want to interface directly with underlying technology and services, right? And then you also want to make the data available for analytics, of course, right? So, data warehousing, third-party marketplace services, or, net or cloud-native AWS dashboard services. So the data lake infrastructure in AWS looks like this at a very high level. We have over 170 services. This is just a subset. But if you take it from the bottom up, we have the ingestion services at the bottom. So this is a subset as well. So as I mentioned, Snowball, Snowmobile, those are for petabyte, exabyte scale migrations. Kinesis is for real-time data streaming. We also have database migration services, server migration services as well. And then when you think about the middle, you see S3. This is our simple storage service, and we'll go in depth about that in the next slide, I believe. But that is really the data lake, if you will. That's the object storage. That's where you can drop all of your files. It scales naturally. You don't predefine storage or pre-allocate. It grows based on usage. So that on-demand tiering cost choices really bodes well here, because you don't have to go into a long-term investment when you're leveraging S3 and you're not locked into using AWS products and services. Again, the decoupling of compute from storage. So if you look at the top, these are all like what we could consider downstream, services or applications that can hook into your data lake. So SageMaker for a data pipeline that's predicated around, training and deploying models into production and doing real-time inference. Redshift, our data warehouse solution, on the right side, services like Comprehend on the developer level to be able to do, to inject a little bit of AI within your application, right? Rekognition. So again, these are all services that you're privy to, once you have, a data lake solution, and even, open source and third-party services are available to you as well. But at the core, just remember, S3, right, is really that central place of, where your data resides. And from there, you have the ability to take it in any direction. So the reason that S3 is a great choice is, one, the durability. So it's designed for 11 nines of durability. So that basically means 99.9 and add 9 more nines % chance that we will not lose your data. The reason is because we actually have built-in fault tolerance and replication across the global infrastructure. So within a given region, right, if you make an S3 bucket, is what we call it, that underlying block storage is replicated across the availability zones within that region. So even in the event of an internal block level failure, it's seamless to a customer, right? We have replicated blocks that will still present that data to you, and your data will not be, lost in the case of a natural disaster. We also have, 99.99% availability. So this is just, how often is the service available? Again, always giving access to data. Very highly performant. So it has different mechanisms to accelerate how you bring data in, how it processes data. So multi-part upload is one, range get. Very simple to leverage. The SDKs, that's the APIs. We have lifecycle policies, so you can tier your data from, hot data to medium data to infrequently accessed to archival and cold, right? So with each choice comes a cost saving. So giving you choices on how you kind of keep that data in perpetuity. It's highly scalable, so you store as much as you need. Scaling of the storage and compute, again, is independent, no minimum usage requirements. And again, it's integrated with all the services you see on the right and many more. We built S3 purposely to serve as a service that integrates with pretty much every service that we have in our platform, right? And this is the reason why it's just a great, choice for using it as the data lake, if you will. So if you look at this graphic, no need to be intimidated at all. Really is just kind of showing the benefits and the different areas in which, you can get value from leveraging the data lake as well as the AWS platform. So when you look at the bottom, you have protect and secure. So these are a subset of, security services like identity and access management for access controls and key management services for encryption, CloudTrail for auditing, right? These are all built in and integrated with, the data lake, or S3 for short. Data ingestion. So there's just a subset of the technologies that we offer and integrate with S3. Direct Connect for customers who have hybrid architectures, who are accessing their data center directly. They can get a direct fiber to go directly into AWS for better latency. Snowball, as we already mentioned, database migration service, a number of different ways to bring data into the platform and just land it. Catalog and search, so DynamoDB, a key value store solution that we have. Elasticsearch, again, which is a fully managed search service that we offer. From the user interface perspective, API gateway, Cognito, right? These are services that can provide, authentication and a gateway to either ingest data into the platform. So some customers, build ingestion APIs, use an API gateway and Cognito for authentication. And this is how they can kind of get data into the platform. So you have a number of different ways to go about it. And then from the right side, there's a number of different products that you can leverage, some AWS, some open source, some marketplace products, right? So real-time analytics, AI and predictive analytics, or AI and predictive modeling, BI and data visualization, transactional and RDBMS solutions, and then analytic solutions, right? So again, this is not a vendor-specific journey, right? As you might see in other providers or other solutions. This is a true customer-driven approach to how you want to, manage your data strategy. You have full autonomy to talk to professionals. We have a, wide partner network, and even internally, we're always willing to help you craft out what your strategy may look like. But again, it's always working backwards from, where you want to go as a customer, and not tailoring you to a specific product or limitations with a certain product that you have to work within. So what can you do with the data lake? So I'm going to take you through various screenshots of just a subset of the services that we have. Feel free to ask questions later. This is a service that we have called Amazon Athena. It's a fully managed query service. It uses native SQL, and it goes against the data lake directly, using Glue as, almost a data catalog. And it has a similar experience with anyone familiar with Hive. For anyone that's, using Hadoop now. So again, it gives you the ability to do ad hoc querying, no sort of setup, You can just open the Athena console and run some queries. So this is really good for ad hoc analysis, for customers. Definitely something to consider when, thinking about data lake strategy and where it fits in. EMR is another, common pattern that we see. So, Hadoop on Amazon EMR, our Elastic MapReduce service. This is more so, for a lot more custom and, more heavy intensive operations you may want to perform in your data lake. So maybe you're doing some, data transformation or some complex, queries across some data sources, and you want to run, EMR. You have that option with our Elastic EMR, with our Elastic MapReduce service. We also have visualizations within QuickSight. So this is a fully managed dashboard service, right? So you can provision a dashboard. You can hook in either views from a database, or you can hook in queries or other integrations from systems to feed data into the QuickSight dashboard. And again, it gives you a nice interactive and easy way to visualize data that lives in AWS. Very easy to provision, very lightweight. A great avenue for, reporting for either executive teams or, any sort of sales related reporting. One of my favorites is SageMaker. So, I've personally enjoyed the data pipeline conversation and kind of exploring, how do I create an effective data pipeline in AWS? SageMaker is a fully managed machine learning service that we offer where you can build and train models and also deploy them into production, via an endpoint that you'll get from SageMaker. It stands up a cluster on your behalf. So it gives you the Jupyter Notebook experience. So you can do, again, you can perform your ETL in SageMaker. And again, you can curate data sets, train your models, deploy them, do your real-time inference. So again, another avenue for, downstream processing with SageMaker. So here's the data catalog that we talked about a little bit earlier. So, this is AWS Glue, our fully managed ETL service. Within Glue, you have the ability to create these data catalogs by using crawlers that actually crawl against your data lake, right? So once you have your crawler job, it runs, it gives you a inferred schema, if you will, on what it found. Within Glue, it has hooks to understand pretty much all open source file formats like CSV, JSON, text files, even compressed formats like Avro, Parquet, ORC, gzip, et cetera, right? So it has the ability to understand a lot of the most commonly used formats and give you a classification, tells you where they're located, and it makes databases within the catalog, which store within the database. It has metadata around the tables that it found to support that database, right? So this is where you would go, or where you would hook your downstream applications to understand how to access certain data, right? And again, this is pretty much, I would say, one of the main important pieces of your data lake, because you want to understand how you're transforming that data, how you're making it available, right, for your end customers. And then, of course, load into downstream services. So, again, talked about SageMaker, Elasticsearch, it provides real-time analytic capabilities. Amazon Aurora is our own internal database solution that we created to kind of solve for customers who wanted commercial grade performance without the commercial grade cost, if you will. So it's a great solution to look into. Whenever a customer is looking to build a data strategy, it has, a high level of redundancy and availability. And I feel like, most customers would get a lot of value out of, exploring with Aurora. Redshift is, on the data warehouse side. So, doing deep, complex analytics against petabytes of structured data. Redshift, and again, DynamoDB, NoSQL database, key value store. Millisecond latency at any scale. I've seen DynamoDB personally used as almost like a lookup layer for APIs, similar to how you would use a cache because again, of the key value nature. Let's say you're running a machine learning pipeline, you've done some pre-computed, analysis. You may want to store that somewhere so that you don't have to, replicate that same process in real time. So, DynamoDB is a good, avenue to take there. So again, that was the overview of, data lake technologies, on AWS. Again, here is the broad spectrum of, everything that data lake has to offer. Again, as Jeremy stated, we're definitely looking forward to, understanding, what avenue, customers, most relate to or would like to dive deeper into, because again, the data lake conversation is a very wide conversation. There's a lot of moving parts there, and it's always important to first have an understanding of the concept of what a data lake can provide, but then also diving deep into certain spokes or downstream, processes, like whether you're a shop that's looking to build a strong data pipeline to support machine learning, or whether you're looking to have a pipeline to provide data to, internal business users via a data warehouse solution, or if you're just looking to have a general data strategy where you can kind of just have a way to have flexibility and just understand how you can mature that incrementally over time, right? So all of those things, again, are very relevant. But my goal for today is just to kind of, plant the seed on, how customers, should be thinking about how they should, enhance their data strategy as we move more into, one, unpredictability around, just the world itself, and being able to be in a position where your technology can allow you to respond in the event that you have to compensate on behalf of your customers, right? So again, as I spoke about the shift in a lot of usage in virtual reality, augmented reality, there's just been a large shift in just the need to have, a large scale of data, IoT as well. Customers are relying more on insights that they're getting from devices, even during the crisis. So again, understanding, how you position yourself, internally based on your own strategy is always a conversation that we're willing to have, and that all customers should be considering, as they evolve internally. So with that, that's all I have as far as presentations. I'll open it up for any Q&A or questions from the group.
Thanks a lot, Corey. That was great. Yeah, so anybody feel free, fire away. We've got some great people from Amazon here today, and it's wide open for anything that you'd like to discuss with them.
Hey there, this is Billy with Pack Health. Just a quick question. I'm actually a big relational database fan, so I've been in that world for a long time. And in the company that we're at now, we have a lot of data that's coming in that, because of the speed needed for the apps, it's like a constant conversation about whether we make it relational or we put it in like a JSON-B column in our Postgres database. So I wonder if you have any suggestions on kind of moving from that model into a data lake. Would you just like throw it straight as JSON files into the data lake, or you have like a migration kind of thought process on that?
Yeah, sure. So I'll take a stab at this one. And Michael, if you have anything, I'm definitely interested to hear what you have to say as well. The way I would think about it is, depending on the requirements for your business, if you have a requirement for low latency access to this data, I would be interested to know, how is this data produced? So is this data coming from like, transactional systems that you have? Is it like an application that you're running? Like what type of data we're talking about here?
Well, most of the time so we have an army of Lambdas that are, pulling data from a couple of different relational sources, or sometimes they'll pull, the JSON will store it as JSON, so it's easy for them to get and use up in the Lambdas is kind of the biggest way we end up creating and using that JSON.
Okay. Yeah, I mean, interesting. So,
how fast from when you pull the data or when the data is ingested till when you need to consume the data out of an application? What's your
Well, I think I'm sorry, did you say from the time that it's created or until the time that it's used?
Yeah, I mean, are we talking, does it need to be seconds, is minutes or hours? Like how fast do you need to report on it or consume it from when it's generated?
Yeah, that's a great question. So so it varies. Sometimes, we're pulling data that could be days old, but sometimes it's like, we created this in this system, so now we have a Lambda that will, ship it over to this other system. So I'm sure that's like oh no, that's why you need a data lake for that piece. But, so it varies. But for a lot of our apps, we want to be able to get the data that we need, and then we need to be able to present it in usually a second is kind of our benchmark that we try to strive for.
Yeah, I mean, and so it's really going to be based on that use case. So a data lake is going to be a fantastic, single source of truth for all of that data in its native schema or its native format. So if it's in JSON, if it's relational, if it's relational, you can drop it down as a CSV or a tab delimited or some sort of delimited file, or you can convert it to JSON after it gets there. But that's where it goes. And then depending on, and we have other use cases, we might use something like Kinesis or Kafka for streaming data in order to get things faster. So I have a customer that went from, what I'll call a vintage model data architecture, very large, big iron data warehouses, multiples of them. And, they went to the data lake strategy. So they kind of peeled off, in ones and twos and threes, all the data sources. And sometimes they paralleled them. They kept it going to the old system, and they put a new stream into the data lake. And as they started building up, some of them, they just did batch copies, hours, days. And then sometimes they're like, you know what, we need real-time telemetry on this. Something like Google Analytics off the website. It's a big retail website. So they want that telemetry very, very fast. So they actually modified it and used Kinesis to stream that data in tens of megabytes a second. And they use Kinesis Analytics to query, you're still using SQL, to query that real-time stream and get real-time analytics. And then at the end of that stream, it's actually still dumping it into S3. So they're able to kind of adjust to what their use case is based on, but still using the same data, right? So you can adjust. That's the great point of this, is you're not fixed because you just bought a product and you have to live within that product. You actually can use all of the tools that surround S3 in order to meet your business goals.
Awesome, thank you.
Great question. Thank you. Anybody else? Feel free to jump in. I mean, we can really.
Is there I have a question. So this is Jared. I work with Compassion International. I'm curious if there is a point in which, the amount of data that you have to throw into a data lake is really not enough to justify a data lake, I guess, in terms of, so I know, like, the end result is, or most cases, it's just all throwing it into S3. But, you know, is there a point where it's a data lake's, you know, like overkill?
So, I mean,
The amount of data you're storing, you know, you talked about it being for, you know, petabytes and exabytes, which is or terabytes and exabytes and all that. So what, you know, is it still good for much smaller data sets?
yeah, so, you know, and I'll take a swag at this one. So what I've seen in customers is, you know, I have some customers who have a small footprint in AWS, and they have maybe a data footprint of, you know, maybe a couple hundred gigs, if you will. But the reason of the data lake is not really predicated on the size. It's more so the standardization and the process that you can leverage to be able to standardize how you're accessing your data. So whether you have, you know, a couple gigs or you have, you know, 100 gigs or either a terabyte, really the power of the data lake is, one, the cost and the complexity doesn't, you know, grow or, you know, prevent you from creating the data lake, right? If you want to produce some sort of insights from that data with an RDBMS or, you know, a data warehouse, you know, you can still go through those same motions with a terabyte of data or, you know, 10 gigs of data, you know, and it's not going to be something that you pay for up front, right? So the storage that you leverage and the cost that you pay for the storage and even the downstream services is all depending on how much data and usage that you're bringing to those services. So, you know, for customers who are running a, you know, 100 terabyte data warehouse or a data lake strategy, you know, their costs are going to be a lot different than someone who's just running maybe 100 gigs or 50 gigs. But the benefit of, even in that latter example, you know, having a pipeline where you have visibility to your ETL, you know, you have visibility to how you're actually processing data from a downstream perspective, is still valuable in any use case, in my opinion. Mike, do you have any opinion on that?
Yeah, I agree. I don't think there's, you know, it's kind of like, you know, there's no job too big, there's no job too small, because the value comes with, you know, number one, you don't, if it's really small data set, it's a really small price point to be able to use it. But you're still getting the benefit of using the pipeline and the pattern so that you can allow multiple parts of your business to operate on the same data, the same truth, in whichever way they deem necessary. I have another customer that, you know, they ingest. They started with, they actually have a lot of machines that they're monitoring all around the world. And they started with 10 machines, bringing that data in to S3. So they're bringing in, you know, the performance data and the alarm data. And, you know, there's collecting some information. Could as easily be financial transactions or, you know, telemetry from their website. So they started with 10 machines. They built the pipeline, and then they went to a partner that their solution was based on a SQL server. And they go, okay, well, what do we do? Well, we've got the data in S3, and we're doing what we want to do with that. Guess what? We can transform that data in S3 and inject it into that SQL Server solution and keep on moving, right? So that it gives them the opportunity to choose products and tools and solutions and plug them in to that existing source of truth. And so now that, you know, that started with 10 machines, which was only a couple hundred megabytes total, you know, after 3 months. And now they've got several hundred machines on that system, and it's working just the same. And the partner that has that SQL Server box, they charge for storage. They charge, the larger that data source gets, the more they charge. So the customer is able to only load the necessary data into that SQL Server versus using that SQL Server for the source of truth, as you might have to do in a legacy approach. So the data lake, it can be big or small, and it doesn't reduce your choices of what you know, what products and services you want to use down the road.
All right, cool. We're using it. We're fixing to help a team migrate into our our account structure, and this was kind of timely for me to kind of wrap my brain a little bit more around, data lake pipelines and how data flows between different and what all the different tools are and things of that nature. So this was great info. Thank you guys for putting this on.
Yeah, great question. Thanks for joining. I guess something else to consider. So we mentioned that this is the first of a two-part series. Corey will be back with us again next month. And what we'd like to do in the June session is get into more of a deep dive of an actual example implementation or some example uses of a number of the AWS services toward some use cases or toward a data lake implementation. So anybody that's in today, it'd be great to hear your thoughts on some specific examples maybe that you'd like to see, or specifics of an AWS service and a hands-on, more tactical demonstration of that implementation, and give us some ideas of how we can tailor content in the next more technical session to something useful for you all.
Yes, David Rutherford with HC3. I guess a general question with data laking, more on an AWS service type question. If, for example, you had a large amount of PDF document, what, other than, I guess, there's always some machine learning solutions, is there any existing AWS service built for scanning and analyzing data out of document level that would be, usable in a data lake site situation like that?
So we do have a couple of services. One that I've used quite a bit was one called Text Extract. I don't know if you've used that before. Text Extract is the AI service, one of our developer services, and it's kind of like OCR, but it has machine learning built in. What it does is, depending on the structure of the PDF, you can extract certain table or column or label type of fields from a PDF, depending on, again, the structure of where the data you're trying to extract is located within that PDF. But text extract is a good starting point, just to kind of play around with and see what you can get back from, running that against your PDF documents. Other than text extract, I would say Rekognition is also a good one. It depends on, again, what you're looking for. I've used Rekognition personally with, getting information from like images and driver's licenses. So I'm pretty sure you might be able to wiggle Rekognition. It would just depend on, exactly what type of data you were looking to get from that PDF. But those two in my mind are the first two that come to my mind. Mike, do you have any suggestions there?
Sorry, I was on mute. Yeah, so, we've used Textract to look at PDF documents. And so, again, some of my are manufacturing based, but had a customer had a QA form that they would fill out handwritten, right? So it was a handwritten QA form. And so what would happen is they would turn that into the quality department. It would take up to 10 days for it to get put into the system, which was SAP at the time. So we used Textract to take a picture of that thing, save it as a PDF, and they would actually extract all the data and post it into SAP from Textract. I got another customer that uses Textract to pull documents information out of PDF and Word files, and they then take that data set and run it through Comprehend. Comprehend is another AI service, just similar to Textract, but it's but it does word index, word count, it does sentiment analysis. It does contextual analysis of the document, and so it gives you a lot of metadata about the document, and also gets you a word index so that you can actually put that into something like Elasticsearch. So yeah, there's a lot of different tools that you can use to work with, and if it doesn't exactly meet what you're doing, then you can go into the machine learning, and do some custom training and all that stuff.
Right. So, but basically, I guess the general routine with something like that would be running a service like that, to extract the data, and that data would then also reside in the data lake and would be searchable at that point. It wouldn't be something where you would initiate a query and it would, go and do a just search of a document. You'd have to run something ahead of time to pre-index.
Exactly. And then we've got another service, Corey, I don't know if you've dug into it a little bit, but we've got another service for enterprise search called Kendra. So think about it as an enterprise search engine with machine learning built in. So, depending on your use case, Amazon Kendra might also be an opportunity.
Okay. Great.
Great. So other questions or ideas of topics for greater depth for next session? I did see that Billy posted a couple notes into the chat. Certainly things we can, I think, great input, and we can take into consideration for designing next month's content. Any other ideas or requests?
This might be a restatement of the first question or the first sample, but it seems to be a pretty common scenario where small businesses have some third-party systems and some internal applications that are storing data in structured databases, but in disparate databases. And the question is does Amazon have a solution for efficiently ingesting data from these various structured data sources, keeping in mind that those rows are not just written once, they're potentially updated, but ingesting all that data and keeping it updated in a central source of truth? And is a data lake a good fit for that, or is there something else that would fit that better?
Yeah, so on that note, we have a service that's called Database Migration Service. And what this service does is it creates source and target endpoints, and then it creates under the hood a replication instance. So basically what you'll have is you have your source database on the far left. Your replication instance would connect into that source database via the source endpoint. And within the database migration service, you can configure ongoing replication, or you can just do a full load, right? So you have flexibility in how you want to handle the migration. So if, for example, I'm storing that data from a target standpoint in S3, I can do something such as, configure my target as S3, which is the data lake. Maybe I want to, retain the column headers so that I can already have some insight into what some of the fields are named. And when I start that migration task, that data is going to continually be pumped into my target for a specified amount of time based on my migration job. Right. So that's a pretty lightweight way that you could essentially have multiple databases that are feeding data on an ongoing basis into your actual target. The only thing to keep in mind that I've seen is that I had a customer who, we did this exercise on an SAP migration. And because the database migration service uses the native APIs, the CDC transaction logs to do the replication, you want to be careful of any sort of forced truncation of tables on the source side and then rebuilding of tables, because that will also take place during the replication. So, for example, my customer, every night they tore down tables and then they rebuilt them. So we kind of had to work around that. And there's ways to work around things like that. But just keep in mind that the database migration service integrates directly with the CDC logs of that native system. So it's going to give you everything just as it's performing on your source, and then, effectively replicate that out to the target to keep those in sync.
Thanks. That sounds like it might be a great fit for what I was describing. And just a point of clarification, I'm just glancing through the documentation there. You can ingest data from multiple data source types like, Oracle or SQL Server or MySQL all into, say, a Postgres target. Is that correct?
Yes. And we also have a tool called Schema Conversion Tool, which kind of plays nice with database migration service. So Schema Conversion Tool is a free tool. Now, this typically is, let's say you wanted to, again, to your example, take Oracle and bring it into Postgres. So you wanted to do a heterogeneous migration. The Schema Conversion Tool one, helps you understand the scope of the migration effort and what conversions can be done automatically, and what conversions need to be done manually, right? So it builds your report, and it gives you visibility to be able to scope out, you know, all of the functions, all of the changes to your objects, any sort of logic you've created, and how it makes its way over to the target, right? So that's kind of the you know, schema conversion tool really is essential, especially in the case of a heterogeneous migration, just giving you that visibility, allowing you to have that report, seeing all of your objects and functions and types, and just knowing with integrity that you're going to be able to bring everything over effectively.
Okay, thanks.
All right, so we're coming up on the hour. We just want to remind everybody of next month's session. We will be following up on this topic with a more technical deep dive. I encourage anybody to reach out afterwards if you have ideas or requests for that. We'd love to hear them. Also taking suggestions for upcoming sessions over the next few months. We have a few booked out, and we're hoping to announce a several-month advanced slate of our sessions in the next couple of weeks. There's still a few openings, and we'd love to have others from the community doing demonstrations in that. It's certainly good to get a diversity of topics and input from our own group. So would love to hear any ideas, requests for topics of future sessions, or any volunteers to do a presentation would be great. Justin has posted into the chat the winners of the Uber Eats door prizes for the month. So please reach out to him with your email and he can follow up with you on that. We'll be posting a recording of this session on our YouTube channel. I'll send that out probably later today or tomorrow to all attendees and to the Birmingham AWS meetup in general. Thanks again, everyone, for joining. It's been terrific having great participation from the local community and keeping this alive as we've been all remote for a while. And we look forward to keeping it going next month. See you all then.